Alright, this is the third video we're discussing fixtures and what you can do with them. One of the things you can do with a fixture is you can use the JDCNC probing routines to help orient the G-code to the physical workpiece that's physically bolted to the machine. Now, let's say you bolt the workpiece down to the machine, and it's not quite straight in terms of the XY plane. Maybe it's sort of 5 degrees crooked. It's just a bit skew-whiff, if you like. So there are two ways that you can handle and align your machining operations to the workpiece. And the first way is that you can just use this to generate edge probing operations. So if you generate an edge probing operation that's got at least, well, in fact, for an edge probing it can have at least one edge. It'll move at -50 and 50 millimeters. Here you can set two values, and you can have it the bottom edge, top, left, right, etc. Any of the edges. Now, once you can run that G-code against your machine, it will probe in, and it'll generate a probing operation, and it'll also generate an XML file, assuming, of course, you run this probing operation on a Linux CNC controlled machine. It'll generate an XML file, and from there, if I just start a new file here, if I generate a fixture, I can right click and I can say import probe data. So that command here reads in the XML file that was generated from the previous edge probing operation. And if I had, and I can choose the XML file. I don't have one here ready, but once I've done that, what it would be is it would have automatically set this XY plane rotation. The rotations around XY, XZ, or YZ. Any of those three rotations, it'll set those values based on the probed coordinates from the XML file. And so, with those values, set to something other than 0, what happens is whenever you, well, let's do a square. Whenever you generate G-code for the machine, sorry, let's just use contour for example, and so if let me just define a touch-off point for that so I don't get the warning. Now, if I generate the G-code for that, it won't see that the G-code, the green line for the feed movements, is slightly off with respect to the machine itself. I can exaggerate that. Let's call it 8 degrees, for example. I'll generate the G-code there. There you go. So you can see that the G-code has been rotated by the rotation value in the fixture definition itself. So this is the example where you would affix the workpiece to the machine physically, and then as a separate thing you would issue an edge probing operation to generate the XML file, which indicates how far off square the raw material is, and then you import that XML file into a fixture object, and that sets these rotation values. And from that point on, all of the generated G-code all of the coordinates for all of the lines and arcs and things in the G-code will all have been pre-rotated by that amount, so that when you run the G-code against the machine, the G-code should line up with the part that's physically on the machine. Now, that's one way to handle it, and certainly that's certainly possible. And if you're running Mac 3 or something other than Linux CNC, then that's certainly the easiest way to do it. But let's say you are running Linux CNC, where it can. Oh well, in fact, let's say you're not running Linux CNC. Let's say oh no, you have to be running Linux CNC for this one, of course. The other way you can do it is you can. Let me just generate another machining operation. I'll stick with contour as it's simple enough to do. Now, what I can do is I'll add a fixture. Now, the other thing I can do is I can, as a child of this fixture, I can add either an edge probing operation here as a child of this fixture. And if I do that, then all of a sudden in the fixtures properties, I get these extra options. I say automatically set the touch-off point, true and false, and automatically set the axis rotation. So if I tick that box there, what happens is when this G-code program runs, the first thing it will do is it will generate a probing operation to measure the raw materials rotation in the XY plane, and it will issue I can't remember what it is, G2L10, or anyway, there's a command you can issue to Linux CNC that says from now on, every X and Y coordinate you get in a line or an arc, I want you to rotate it by this amount. And so what this probing operation does is it probes the points, it calculates the rotation from straight, and then issues that command to Linux CNC, so that all of the G-code that gets generated from then on is all automatically rotated by that amount. So you can see that the G-code as it presents on this user interface is not rotated at all, because JDCNC doesn't know how far off it's been rotated at runtime. It really is an all runtime thing. So that and one of the edge probing operations can be added as a child. Now the other thing you can do is like if the edge probing operation has got 2 edges, for example, instead of just one, then that would say, let's say, probe the bottom left corner. So it would probe along the vertical here in the y-axis, and it would probe along the x-axis, and where those two points along here and 2 points along there. Now, where those 2 lines, by joining those points, intersect, it could be used to automatically touch off. So automatically set the touch off point. If I have that set to true, then I have to have the touch off point defined, and whatever value I have in this touch off point for this fixture, once it probes these 2 edges and finds the intersecting point, the G-code will automatically issue the commands to the Linux CNC to assign that coordinate, to assign this coordinate, the touch off point coordinate, as that location on the machine. So that's one way you can do an automatic touch off at machine runtime rather than before you run the G-code. Of course, in order to do that, of course, you've got to have the touch off point roughly set. You'd still need to put the workpiece down, you still need to move the machine and manually touch off and say, well, that's around about where it is. But all that that rough setting is really so that the probing operation sort of knows roughly where the workpiece is and where to start from. So you do have to do a manual touch off, but it doesn't have to be accurate. But these by adding these probing operations of children of the fixtures, it can automatically assign both the touch off point and or the axis rotation values to the G-code. Now let's say, for example, the edge operation you put only as one edge. So let's say you wanted only the bottom edge probe, so it would only probe 2 points along this bottom edge. Well, that's enough to set the axis rotation value, but you can see that the automatically set touch-off point value is now being removed from these fixture properties. But so I either need to have an edge probing operation that has 2 edges being probed, or I can also add a center probing operation. And the center probing operation, normally you'd have maybe 2 points instead of 4, and we can do either inside or outside. So normally you could do an outside along the y-axis, and that will generate a probing operation down here and down here, and find the center point halfway between those points, and it would set the and if you have the touch off points automatically set touch off point, then the coordinate in here would be assigned the center point between those 2 center probed coordinates. Anyway, I know it's a bit long-winded, but that's the thing. So really, these are 2 different ways of having the G-code align itself with the probed orientation of the workpiece. And as I say, you can either probe it ahead of time and import those probed XML file coordinates back into the fixture so that all of the G-code is pre-rotated, or alternatively, you could add these probing operations as children of the fixture object, and the probing operations will occur at the beginning of the G-code program, and then as soon as they've been done, they will implicitly set the rotation value and or the touch-off point, and then it will just continue on the rest of the G-code program from there. And of course, you can repeat this for as many fixtures as you want. If I wanted to have a G55 and things, you could do the same thing here. So I could say add an edge probing operation for G55. let it have two edges, bottom left, bottom right, however you want it to be, and that's how it'll go.